G'day guys, how you doing? So here we are, 2nd of May, and we're going to be doing our bracing and our framing unit, and I'm pretty sure that it's actually module 8 in your folder. So yeah, maybe just yeah, type in the box or just say yes. You can hear me if I'm coming through okay. Yep, it's all coming through. I'll just chuck it on mute there for a second. It sounds like a bit of feedback coming through. Yeah, cool. And I don't think by the names, guys, that I think I've recognised all the names. There's anyone having their first night tonight, on as far as the online sessions go. Oh, Nick is. Okay, cool. No worries, Nick. And Ben. Cool. I've obviously seen your names on there before, but must be the first time you've actually logged in. Cool. So what I've got at the moment, what I ask is just because you should have a button on your end if you've got a microphone where you can actually mute yourself. And I just ask that everyone sort of mutes themselves. Otherwise, you get a lot of background noise because there'll be probably 14 people on tonight. And then we get 14 people's background noise and it gets a bit loud. So I just ask that you mute yourself, and then when you want to talk, then just unmute and talk to me. And or if you prefer not to talk, you haven't got a microphone, you can just type in the box where you have there, and yeah, and I can see your question and answer it that way. So depending on whether you've got a microphone or not. So I'll just take everybody off mute for a second now and see how we go with the feedback. So cool, Nick. So tell us a bit about yourself, mate. Yeah. So what license type are you going for?
I'm going for DBM.
DBM, cool, no worries at all, mate.
I have been attending the classes Mondays and Wednesdays for the past 8 weeks.
8 weeks, yeah, cool, no worries at all.
And I recently found out about the online class the first night.
Okay, cool.
That noise, by the way, is not me.
No, that's all right. That's all right. That's amazing. One out of the what I'll do, I'll mute everybody and I'll unmute you, mate, so we can have a little bit of a chat. 1 second. All right, cool. So I've taken you off mute there. So yeah, yep. so which location are we actually doing the classes at? You know, sit down at Braceland or Springs?
Braceland, yep. My Braceland, by Wednesday nights.
All right, cool. No worries at all. All right, so have you actually done this unit before, Nick, or is this the first time doing this unit?
The actual unit's the first time working through the folder, because we never do work through the folders in class.
Okay, all right, cool. Now you'll find the way that I train, and I'm sort of very structured because I know the guys sort of drop in for a lesson. Some guys do the whole course online, and others go, hey, I'd just like to touch up on my framing again. So they just drop in. So you'll find tonight I'll actually just teach that whole section of module 8. So yeah, I sort of do it, I suppose, a bit more structured to the other guys, just purely because people are coming into the class just to get a certain bit out of it. So I make sure I cover the whole thing. So yeah, so I'll make sure that we go through all that, and then sort of towards the end, if I've been given any updates, anything that's new from basically our sort of head office or feedback from any students who have gone through their interview process, then I'll basically talk about that as well and share that over. But yeah, nothing new tonight, guys. So yeah, we'll just be basically going through tonight's lesson, but always hang around if anyone's got any questions. So what I'll do, Nick, I'll just chuck you on mute again. I can see Ben, it's your first time. I'll just chuck you off mute for a second, Ben, if you've got a microphone. Yeah, so you there, Ben?
Yeah, g'day, mate.
Yeah, g'day, mate. How are you?
Yeah, good, mate.
Cool. Yeah, so what's your background, Ben? So which license type are you going for?
I'm going for a DBL.
Yeah, cool. And which one, mate?
Oh, I'm just the non-applicable structures.
Yep, okay, non-habitable. Cool. So, yeah, so you do probably a lot of sheds and garages and stuff like that, do you?
Yeah, boat sheds down the beach.
Oh, okay, cool. No worries. You know, I've got a guy I train in one of my face-to-face classes, and he's going for his non-habitable as well. So once I'll actually be able to put you guys in touch. He actually owns his own shed business. They're called sheds and something anyway, and he's basically the distributor for the sheds, but then he actually has to give it out to somebody to build it, and so now he's going to do both. He's going to sell the shed and then actually build it. So yeah, and we don't know anyone who's actually gone through yet on their non-habitable structures. So yeah, I'll give you his number and give him yours, and that way whoever goes first, yeah, you can basically Yeah, that's it, Tom. It's Sheds and Homes. Yeah, so I'll put you guys in touch. So whoever goes through first, you can give the other one a bit of feedback on what to expect when you go in.
Yeah, cool. That would be good.
Yeah. So is your application has gone in yet, or you haven't actually lodged it yet?
Yeah, it's all gone in. I'm just waiting for a date.
Okay. No, you're probably pretty close then, because he put his in a few weeks ago as well. So you'll probably be going in roughly about the same time. All right, cool. So,
Yeah, cool.
so this will be something that you'll do in your license as well. I don't know how hard they go on it with the non-habitable license, but still you want to be able to cover, obviously, your framing and your bracing. So have you actually done this subject before, Ben?
I think we went over it in class a few weeks back, but nothing too major. I usually go in on Mondays, but I couldn't make it last night, so I thought I'd give this a go.
Yep, cool.
Just to catch up.
Yeah, no worries at all. All right, cool, mate. No worries. Well, what I'll do, I'll just chuck you back on mute. So we do get a fair bit of feedback when everyone's got it open. So if you do want to talk, just type in the box and say, hey, Adam, can you unmute me? And then we can have a chat about it. So I'll just chuck you on mute now, mate.
Beautiful.
Cool. Yeah. Saw your question there, Valavan. I realise a few guys like you yourself too, who just basically do the online version, and that's why I try and obviously give you guys as much feedback as I can, because this is your, I suppose, one point of contact for the week. So that's why I always sort of send over the answer guides and any other stuff that's relevant as well. So if you are on for the first time, just so you're aware too, I do actually record these basically these sessions that we do, and because some of the guys who Valavan, who does this as his sole basically contact with builder registration, if he misses a session or he wants to go over it again, I just send out a link. I've got my own YouTube page, and it's funny, I probably sound like I'm some tech guru, but I'm not. I'm a chippy who has fumbled his way through the system. But yeah, what I can actually do is make it what they call unlisted on YouTube, so the only people who can view it is if they've got the link. And so yeah, I just like to tell you before you obviously start talking and you record it and it's on YouTube for the rest of your life. But yeah, so I do actually put it on YouTube. So it can be taken down also, but I'm going to get a library basically from basically all of the 12 units that we actually do. And so therefore, if anyone ever wants to brush up on something too and go, geez, I'd like to go over bracing again, then rather than waiting 12 weeks for it to come around and get into a class, we can say, hey, listen, here's the link. Have a read over this and see if it's any help to you. So yeah, so that's there's a few other people logging in. I don't know if there is anyone else's first night, but if there is, if you get lost, guys, because it's your first night, just type in the box and definitely let me know. But basically the way the system works is whatever's on my screen, you guys actually can see on your end. So I've got two computer screens set up. You can do that, Wayne. I'll make note of it. Sorry, Wayne just asked me a question if I can send in last week's session. So I'll just make a note of that, mate. Yeah, cool. I'll send that probably after tonight's or when you guys are doing an activity. So yeah, so the way this works is basically I've got two computer screens set up, and one of them you guys see whatever's on there, and then the other one is where I have the sort of, I suppose, the actual session feedback, which you guys are actually typing me questions and stuff. So that sometimes you might see me trying to bring up different documents. It's only because obviously with the folder you guys use in a classroom scenario, it's a lot easier for me to open up my folder and say, let's do this exercise. So there might be the odd time where I sort of have to fumble through, because at the moment I've already got about 5 documents opened, and you guys can obviously only see the one. So anyway, we'll get started. So tonight what we're going to be doing is our module on our framing and our bracing. And what I like to do is just start on the bracing first. I find it's probably the part that, if you take a little bit of time to grasp it, don't worry. Some people grab it like straight away, and within 5 minutes, like, wow, I can do that. And other people, it might take 10 or 15 minutes, and we'll do a couple of exercises, and then basically the penny drops. So yeah, the first couple that we do, yeah, if you're confused, don't worry about it. We'll keep soldiering on, and I'm sure you'll grasp it by the end of it. So what I like to do is just talk about the different aspects of our bracing. So throughout the course, whether you've been doing it online or in a classroom environment, you've probably been have your trainer talking to you about, okay, let's tab this part and let's highlight this so that we know these are certain parts that you're going to be asked in your license. So we'll definitely still do that tonight, but I also like to show people where to find it, just in case you're in there and you get asked a question that you haven't been trained by builder registration, so you sort of then know how to navigate through basically the Australian standards and your building codes and also your legislation books. So I'll just shrink this a little bit. So we are using 1684 tonight, and so we're going to be doing bracing. So just so you know, if you had to find something in here and you go, geez, I don't remember doing that in the course, all you do is come to your table of contents, and hopefully from doing the course you would then start to know, okay, well, what am I looking at here? Am I looking for something for termite management? Am I going to framing, flooring and decking, floor framing or flooring and decking? Am I doing wall framing? And you just basically go through your sections. So what we're going to be doing tonight is actually bracing. So you can see here that our bracing starts in section 8, and on this PDF it starts on page 80. So that's where we're basically going to be going. And what we'll talk about tonight, I really want to cover just, I suppose, the beginning elements that you guys might get in your multiple choice, where it talks about nominal bracing and the percentage you need, what a type A brace is and what a type B brace is. Also, there's got something to do about how much temporary bracing that we need. So we'll talk about these different types of bracing, and then from there we'll actually go into the design phase of, okay, now I've got these plans and I've been asked to actually design the bracing for that house. How do I do that? And that's basically what we'll do. So I'll just go to page 80 and bear with me a second. So you'll notice too, if you guys actually are doing this as a PDF, you can probably see my screen up the top here where it's got page 7. So even though it says on the book here it's on page 80, because it's actually a PDF, like the first couple of pages as far as the cover and the inside of the cover are pages 1 and 2. So if you're wondering why I'm typing in page like 84 and it says page 80, it's just because these numbers don't correlate exactly to when it's in a PDF. All right, so I'm just going to go to page 84 to try and get roughly about where the bracing starts. Yep, nearly there. Oh yeah, that's made a liar of me. It did start on 80. Oh no, it didn't. There we go, so page 80 and it's 82 up here. All right, so the different things you can see there on section 8, we're on bracing. And you'll hear me flicking through my book because my book's got a lot of highlighted stuff in it, and then I bring it up on the screen for you. So the first part I want to talk about is temporary bracing. You can see I've got it highlighted here. So this might be something that you'll get in a multiple choice test. Yeah, probably the guys who are doing your DBM, your DBU, or your DBL in carpentry. And as we just spoke about there before to Ben, how he's doing his non-habitable, at this stage, they don't have a multiple choice for you, Ben, but it might be something you need to be familiar with anyway, so it's definitely worth understanding and noting it in your book. So when we're talking about basically standing our wall frames and so on, it just says temporary bracing is necessary to support wind and construction loads on the building during construction. Temporary bracing shall be equivalent to at least 60% of permanent bracing required. So that just might be something in a multiple choice where it'll say, what is the percentage of temporary bracing needed? And you'll have the, 25%, 40%, 30% or 60%. So if you want to highlight that, and I've just got a tab basically on my Australian standard that says bracing, and then I just know that if I get a question on bracing, it's going to be in these next sort of 5 to 10 pages. So that's something that yeah, definitely highlight it because it's quite popular in the multiple choice tests that we do. Also, not that we do, that the VBA do, and if you've been doing any practice ones with us, you would have actually seen that in there, I'm sure. So then we'll come down here to actually our wall bracing. And it just says here, bracing, structural wall bracing is classified as type A or type B bracing units. And it'll tell us a little bit later on about what a type A and a type B is, and I'll show you in the standard basically what that is. It's really a different bracing when we've got ply, we've got speed bracing, angle bracing, there's different sorts of bracing. Basically determined on the strength is what makes it type A or B, and I'll show you that shortly. So walls shall be permanently braced with any of the described bracing units or a combination of bracing units. and we'll see these ones a little bit later on, the different combinations we can use. And it says nominal bracing as defined in this clause here may provide up to a maximum of 50% of the total bracing required. So I would highlight that 50% part as well, and I'll talk about that shortly, because some of you might be going, well, geez, we just spoke about temporary, now we've got nominal. Bloody hell, what's this nominal bracing? And me being a carpenter, to be honest with you, I'd never heard of nominal bracing. Probably like most of us, we just get the plans and it says this is what brace you're using and this is where it goes, and you put it on. But so yeah, we do know that nominal bracing can make up basically 50% of what our bracing units need to be. So then when you're going, okay, Adam, that's great, what is actually nominal bracing? What I'll do, I'll just flick over a page or two. And in a nutshell, what basically nominal bracing is pretty much your wall linings. So if we read, oh, we've gone too far. Here we go, this part here. So if you're wondering what nominal bracing is, I actually got this highlighted just in my own book because I inherited this PDF, so I actually didn't highlight the PDF stuff in it. So basically I've got this highlighted in mine. I might make that a little bit bigger for you. So nominal wall bracing is framing lined with sheet materials such as plywood, plasterboard, fibre cement or hardboard or similar materials, with sheeting fixed in accordance to the relevant Australian standards, and the wall frames nominally fixed to the floor and the roof and ceiling frame. So we'll look a little bit deeper into that, but basically what's telling us is when it says your plasterboard, so just here, so if we were going to put an angle brace on an internal wall, we can actually use plasterboard as an alternative to that angle brace. So yeah, me personally, I've never put nominal bracing on, but if you wanted to, you could actually do it. But the main part we need to be aware of, if we are using nominal bracing, if we're going to use plasterboard, it needs to be fixed to Australian standards. So if you looked at Australian standards of plasterboard, you'd probably be shocked that, well, you wouldn't be shocked, but there are probably not many plasterers who actually fix it to the Australian standard. Yeah, when it talks about the amount of screws you've got to put in your, basically where your joins are, in the internal corners, you know, how often you've got to put the glue and stuff like that. But not only that, when we come back here a little bit, and so this actually talks about our nominal bracing, because when I spoke here about saying that we can use plasterboard, well, the next question is, okay, well, how much plasterboard do I have to put on that wall to actually for it to be effective as a brace? So that's when we look over here, and it tells us here on the page before that. So one thing we definitely want to know, so I'll highlight this as well, is 1 type B bracing unit equals 2 type A bracing units. So basically your type B is twice as strong. So if we were to look at our different types of bracing, which we will shortly, if we were going to say an angle, a bit of speed brace was type B and our ply was type A, so basically we would have to put 2 speed braces there to do the same job as what one bit of ply brace would be. So that's in a bit of a nutshell. I'll show you in greater detail how that's got to be fixed and so on, but you really want to know that part there. So highlight that 1 type B bracing unit equals 2 type A bracing units. And then when we were talking about this this plasterboard, how much do we have to put there to make it actually efficient as a brace? So if we've got 7 meters of single-sided nominal bracing, that's going to basically equal 1 type A bracing unit. Or if it was going to be basically 4 meters of double-sided, that equals 1 bracing unit. So yeah, when you're maybe talking about external cladding, if you had, you know, some type of cladding on there and it was fixed to the Australian standards, and basically it was a 7 meter run, then that's going to be equivalent to 1 type A bracing unit. Or on the other side, if it was going to be an internal wall and that wall was 4 meters long and we had plasterboard on either side of that, that double-sided plasterboard 4 meters long is going to be doing basically the same job effectively as what a type A bracing unit would be. So there's a couple of things you might want to basically highlight in your book. Definitely that 1 type B bracing unit equals a type A bracing unit, and that little part there. And I'll talk to this one a little bit later on. So then the other thing I just want to show you too, which is down here. So when we're talking about our bracing, so just be aware that unless otherwise noted, that sheet bracing units shall be a minimum of 900 millimeters wide per type A or type B bracing unit. So when we're using our ply, and as I said, when we talk about the way that it can be fixed and the tie down methods we can use, that's what differentiates between our type A and B when we use ply sometimes. They have to be a minimum of 900 millimeters wide to basically to achieve that rating of what our bracing is. All right, so what I'll do now is just show you a couple of different bracing units and how you can sort of work out what they are. So this one here is basically showing us two diagonally opposed timber or metal angle braces. So it's going to be in the one wall because they're actually opposing each other, one going that way and one going that way. So that's going to be a type A unit. So it talks about here, basically how it's got to be fixed, that it's a galvanized metal angle, and talks about, the size of your nails, how big that metal angle has to be. And probably another one too you might get in multiple choice or need to talk about is actually the angle of the brace. So ideally we put it on 45 degrees, but anywhere between 30 and 60 is effective. So it might be another question, basically what is the angle that a brace needs to be, an angle brace needs to be, it's between 30 and 60 degrees. So here's another one too. So this is our metal strap showing us. So that's another one. So it's also a type A. So that one there is just as strong as this one here. And same thing, it talks about how it's got to be done between 30 and 60 degrees. It talks about our minimum and our maximum measurements. Basically that these can actually be, and then talks about how it's got to be fixed. So then I'll come down to this one here. So this is basically our type B, and so remember our type B is twice as strong, and basically at a close look, you guys might be looking at that going, hang on Adam, that looks very similar to the last one that you did, but what makes this one different is basically this strap over the top. So once we put those straps over the top, basically, and you can still see here, it's still the same angles, and it's still pretty much got the same types of fixings and so on, that it becomes basically a type B. So when you're doing your little plans a little bit later on and you're nominating where you're going to put these braces and how many, they can actually be a combination. So you might find that the wall's not long enough to put a heap of type A's in there, so you might put 4 type B's and 2 type A's, and we'll touch on that a little bit later on. So where are we? Here's basically some ply bracing, which is method B. I'll just shrink that a little bit. Sorry, not method B, that's actually type B. And so you'll talk about here, how it's got to be nailed. And then these are your different methods of how it can be fixed down the bottom. And it says here that note each panel has to be 900 millimeters. So these are basically the way that it can be fixed into the slab. And we can use M12 rods, or it says method B, or it says or an M10 bolt or any other 13 kilonewton capacity connection at each end. So, and then immediately at 1200 millimeter centers. So when it says 13 kilonewton, because as you know guys, there's so many different ways we can fix our bottom plates to our slabs, with all the different chem sets and all the different stuff, all the dyno bolts and all the Ramset products and so on. So as long as that is rated to 13 kilonewtons, then it's okay. So obviously they can't list every product that comes out, so that's why they put an M10 bolt or other 13 kilonewton capacity connection. So that's a type B. And this one here is basically a type A. So just remember what we spoke about, that our type B's is stronger. So even though this is ply, if you were to read how it's all fixed, it would be different. And that's why it would only come to a type A. But if we are doing it like this and having these connections, then that's why we're actually making it to a type B bracing unit. So you can look through there. There's lots of different bracing ones, and yous are on site, so you would see them. But yeah, me personally, probably the most common ones that I've used are these ones here, and I actually have done the majority of my building in Queensland, and just because of our wind rating up there, this is pretty much how we do it. You can see this here. It shows you've got this threaded rod through there, and that was something that we used to do, basically those every 1200 millimeters, and they'd be chem set into the slab, and you'd have these threaded rods going all the way through, and if you had a 2-story, it'd basically go from the slab all the way through to the top plate of the top floor. So yeah, you might not be familiar with all these, but as long as they are going to be type A or type B, you can actually make whatever selection you like that's going to work for you. So there's a little bit of information about the different bracing types. So by all means, if you're not familiar with them, have a read over them, and depending on your license type, if you want to at least be familiar with the ones that you're using on your site, and maybe just look at it and go, oh, okay, I've seen that, yeah, that's actually a type A. So try and get a little bit familiar with them, because they are something that's pretty applicable to most licenses that the VBA are asking you about, unless you're obviously doing a finishing license, you know, along like your plastering, your tiling and stuff like that. All right, so I thought what we'd do from here, guys, is I thought I would just take you through how we actually work out. Now we've got a little bit of an understanding of our nominal bracing, our bracing types, how we actually work out basically how many bracing units that we actually need. So bear with me a second, I'll just bring up the page. So this part here, it's on page number 83, and depending on, you know, how confident you are with this, it's probably not bad just highlighting this in case if you feel like you're going to have to go back and reference this at a later date, because this actually steps you through how you actually do it. So if you go, yep, okay, I'm all over this, and then all of a sudden it's, you know, the VBA is so slow and 6 months down the track and you're having your interview and they ask you to design it, you go, oh geez, I remember Adam teaching me this. If you read through this, you really can't go wrong. So this is the procedure to work out our bracing units. So I'm going to read through this and then sort of explain it as we go. So the first thing we need to do is determine the wind classification. So obviously on our plans, it's going to have our wind rating. And what I've just done a little basic thing here. I'll just bring this over, because I didn't want to use the ones out of the book just yet for me to sort of step you through it, because I'd like you to do 3 on your own. So I've just done basically a little elevation there, on an elevation like a floor plan, I suppose, of a building. And I know it's pretty basic, saying it's because obviously I don't have AutoCAD, I've only got Microsoft Word, saying, you know, this is basically from above, that this wall is 14 meters long, and this wall basically running up and down is 10 meters. And I've said here that it's an N2 wind rating. It's a single-story house with a 25-degree pitch roof. So that's normally the information that you will need to actually work out your bracing units. So the first step was on there was to basically, it's not going to let me highlight it anymore, was to basically determine the wind classification. So from my diagram that I did there, we can see that it's an N2. So that's the first step done. So the next one, it says from figure 8, I'll read through it first. So from figure 8, determine the appropriate house elevation. So I'll highlight this. The appropriate house elevation option for single story or the upper story, or the lower story of a 2-story construction for both wind directions. So what we're going to do, this here is our figure 8, and so we're going to look at it and go, okay, well, if it's a single story or it's the upper story of a 2-story house, they're basically done the same. So we use this one here. It says here, this is for single story or upper story construction, and then this one here is for lower story of a 2-story construction. So if we come back to my table here, we can see that it's a single story. So when I open up the PDF again, we can see we're going to use a single story. So I'm just going to, don't confuse, bring it down a bit. So we're going to be using these options here. So okay, it's single story construction. So the first thing we need to then work out is for both of our wind directions. It says here for both wind directions, just this part here. For both wind directions, we need to basically match it up with one of these elevations. So when you look at my drawing here, so why don't we call, coming from the top, we'll call this A, and we'll call over here wind direction B. So if we're looking at A, and I might just put this in here because I'll forget and confuse myself and then end up confusing you guys. So I'll make that direction A. So the wind coming from direction A, the house is 14 meters wide. So when I come back to here, we go, okay, well, this is only up to 6 meters. This direction is only up to 12 meters, and this direction is up to 18 meters. So therefore, 14 is too big for the 12. So we've got to use option S3. So that's basically, if you're getting a bit confused, don't worry about it, because we're going to get this information and put it into a table very shortly. So just to make it clear, what I might do is come back here and say, yep, this one here is option S3. So we know that that is basically for designs bigger than 12 meters, but no bigger than 18 meters. So we've worked out S3. So then when we come back, we need to then figure out for direction B. I'm just going to put a B here so I don't confuse me and yourselves. So direction B is actually 10 meters. So the wind blowing from left to right is that length of the wall is 10 meters. So I'm going to come back here. Okay, well, it's bigger than 6, but it's smaller than 12, so it's option S2. So I'm going to write that in here. All right, so if I come back now to my standards, you can see here that we've done the first two steps. We've determined our wind classification was N2. Then we've determined, which type of these figures that we need to use. And then it says, okay, the next step is go to table 8.2 and determine the number of bracing units required for each wind direction. So if we scroll down, this is in table 8.2. So this is when we start to line up all that information. So if we come back to my little dodgy plan I did, we know that we're doing N2. So go N2, okay, I've got to be using this table here. We're not going to use the top one because this table we're using an N2 wind classification. And then we determined that our house was a single story. So therefore, we've got to be using these figures in here somewhere. Sorry, I meant to highlight all of those. Let's see if I can highlight it. I've just got to be using those figures. So it's N2 and it's single story. So then we go, okay, what was our house elevation? So the first wall we'll do is let's do basically wind direction A, and we said our option was S3. So we're going to come back to here. So we've got an N2 wind rating, single story, and our house elevation was S3. So we've got to be on this bottom line. So now the only other thing to determine from there is what was the pitch of our roof. So this one here talks about wind on vertical surface elements, basically gable and skullion ends and flat walls, and on elevations with a roof pitch of up to 5 degrees. And this one here is wind on elevations with a roof pitch greater than 5 degrees. So I determined that our basically roof pitch, if we come back here, was a 25-degree pitch. So that's the last piece of the puzzle. So the 25-degree pitch is greater than 5 degrees. So therefore, we need 22 bracing units. That's type A. So this is type A bracing units. So just to run through that again, it was N2, was single story, our elevation was S3, and therefore I come across the roof pitch was actually greater than 5 degrees, so therefore I need 22 bracing units. I'm going to write that there. So I need 22 units to basically counteract that wind. And so just remember, with that wall there, that 14-metre wall is running from left to right, so it's running horizontally, so that for the wind, oh geez, what did I do then? The wind is basically blowing against that. So in order to counteract that, we don't actually put those braces in those walls. They need to be in these walls here that are basically going to counteract that wind. So just be aware of that we don't obviously put those 22 units in the 14-metre walls. We actually put them in the ones to basically brace against the wind coming in from that direction. All right, so we'll do the next wall then. So from wind direction B, we've got here, we'll go back to our table. So we're using N2, basically single story. So I'm going off memory here, single story. And what was our elevation? Was our S2 because it was 10 metres long. So I'm going to use S2, which is on this line here. And then we come across to the far right because it's greater than 5 degrees, therefore we need 11 units. So we come back to here, and so basically when the wind direction is coming from left to right, we need to put, how many units did I say? 11, basically in these walls to basically counteract that wind coming from left to right. So now we know how many units that we need. Now when it says 22 type A units, you might go, geez, that's a lot of braces. So that's when we can start to use type B. So 1 second, sorry, I just got a question there from Subit. I'll talk to you in a second, but that one's Subit. So you can have 22 bracing units. Geez, I'm going to run out of room. So that's when you can start using type B and going, okay, I actually only need 11 type B units. Let's use ply bracing, or let's use one of these strap braces that equals a type B unit, and therefore, we can cut that down to putting in 11 type B bracing units. Or it can be a mixture. As long as the total adds up to that 22, we don't care how we get there. And I've just got a question here from Subit saying, yep, cool, no worries at all, Valavan, I'll get to that. Subit's asked me, how do we calculate basically like the nominal bracings? So when we go, to be honest with you, my advice would be when you go into your interview, and if you get basically asked to do this, I wouldn't complicate it by putting nominal bracing in there. whilst it can be done, I'd just be putting in type A and type B, because the last thing you want to do is get too complicated for the assessor and go, geez, what's he doing here? If the plan's not to scale or something and you're saying this is a 4-metre wall, so I can plasterboard at both sides, and then on scale it might only 3.6 metres, whatever it's going to be, I wouldn't be too concerned about putting nominal bracing in when you're actually going in to do your test. I'd just be putting in type A or type B unit and using either strap bracing or your plywood bracing. So, but if you wanted to do that, Subit, just let me bring it back up. All you would have to do is go to basically like the nominal bracing section, which says down here, and says that we can actually use 4 metres of double-sided nominal bracing equals 1 type A bracing unit. So if you had a wall that was 4 metres long and it had basically plasterboard fixed on either side to Australian standards, then yeah, that could make up 1 type A bracing unit instead of putting an angle brace there. But I would just be saying type A and type B, and then saying type A is strap bracing or angle brace, whatever you want to use, and my type B bracing units apply. And that's really all they're going to want to see. So I've just got a question here from Valavan, how to determine A and B again. So I might just take you off mute, Valavan, so we can chat for a second. So are you just talking in relation to the wind direction, how I've called it A and B on here? Is that what you're talking about, Valavan?
Yes.
Yeah, so so you've just got to, how do we determine it? So yeah, basically I just called that wall there because you've got to have a wind direction. So I've just called that wall there basically wind direction A. So that's the wind coming from the top of the screen down. And I've just called this wall over here, which I can't highlight, as basically B, the wind direction blowing from left to right.
You just named it, are you?
Yeah, I just named it, yeah. And you'll find normally when the plans that we actually give you, it'll have on there with an arrow, almost like how normally on plans you see, where north is. The plans will normally have like wind direction A and wind direction B. So it'll then show you which way that's actually blowing. It'll be a lot more better explained in our documentation rather than on this little Word document. I just did this up this afternoon to try and use it as an example.
Yeah, I thought it's just something to do with type A and type B.
Yeah, no, it doesn't. Sorry, yeah, I probably should have used different letters actually. That's a good pickup. Next time I'll use wind direction D and F or something. might be less confusing. All right, cool, mate. I'll just chuck you on mute again. Oh, sorry.
While you're on the topic, Adam, just a quick question. If if a wall A, if we stepped it, say 14 meter becomes like a 8 meter and 6 meter, and do we need to count as a 14 meter or?
Yeah, sorry, I get what you mean. No, it's the overall length. So if you look at this picture back here, you can see this one here. There'd be a couple of different walls on there. This one here might only be 4, that might only be 6, and that might be 8. But when the whole basically length of the whole length of the building, I suppose, because the wind's going to be blowing against that whole face of the building. So therefore, it's an overall length. Yeah, and we'll do a little exercise later on where our house has got a few step-ins on it, but you just do the overall length of the wall. So as long as that overall length is less than 18, and some of you might be thinking, hey, I've seen stuff that's bigger than 18 metres, and I know my house is deeper than 18 metres, but that's because that's the actual limitation of this standard. This standard only designs buildings up to 18 metres. And I think, I forget the height of the walls, it might be 2.7, but it talks at the beginning of the standards about what the limitations are of this standard, and that's one of them, is that it only designs buildings up to 18 metres. All right, cool, mate. I'll just chuck you on mute for a second. All right, cool. So, yeah, so now that we've gone here and we've actually determined these number of bracing units that we need, and so I didn't write down how many we needed for the other direction. Must have been 11, I presume. So if it wasn't 11, don't shoot me. That's not that vital if I write that down wrong. So basically, once we've got our units, so basically from there, when we come back to our instructions on how to do it, so we've worked out what our wind classification is, we've worked out what our elevation is from down here, and then we've worked out our number of units. So the last step, the last piece in the puzzle is actually how do we actually place those bracing units throughout the building. So it says distribute the structural wall bracing units evenly as in figure 8.4. So if I scroll down a bit, there'll be a diagram here that starts to show it just after all the different bracing types. So this here. So this is talking about the distribution of the bracing. So bracing shall be approximately evenly distributed and shall be provided in both directions, as shown in figure 8.4. So as I was showing before, if you can see my mouse, when this wind is moving in the direction of basically where these two arrows are, the braces that are actually bracing against that is number 5, 6 and 7. Because and then the ones where the 3 arrows are coming from, the braces bracing against that is actually 4, 3, 2 and 1. And so it says bracing shall be initially placed in the external walls and where possible at the corners of the building. So we want to try and get it in the corners, as you can see here, and that might not always be possible because there might be big glass sliding doors or big windows. But this just says if possible, basically external walls first, definitely external walls first, and then where possible at the corners of the building, and then the rest of that bracing should then be evenly distributed throughout the internal walls. So we'll do some stuff tonight when we do ours, and I'll put up an answer guide. And I can guarantee you, if we've got how many people on tonight, probably we've got 15 people on tonight, and we could get 15 different answers and they could all be right. Because as long as we're distributing them evenly, how we decide to our starting point, they're all probably going to be a little bit different. And then the other thing, the distance between the bracing units at right angles to the building length or width shall not exceed 9 metres. So they can't be any basically more than 9 metres apart. So if you've got a really long wall, like we saw that, how it had basically our 18 metres long, they can't be any more than 19 metres apart, those bracing units. So that's pretty much what I wanted to show you how the bracing works. And I thought we'd do a couple of exercises. And what I'll do, I'll just I don't want to leave this up too long for you guys because it's got the answers on it, but just to give you a bit of an idea of how, this is one of the ones we're going to do a little bit later on, of how you could actually basically mark this on your drawings you're doing now, but then also when you go into the VBA and you might have your exam. So as you can see here, they've worked out the amount of bracing units and they've started on their corners and decided to put, Bs. And then because of this measurement here, you can see that it's 12 metres. So therefore they're going, okay, they can't be any more than 9 metres apart. So they've chucked another one in the middle. So they've basically started on their corners and then made sure that they were no further than 9 metres apart. And then after that, they've then started to distribute these evenly on the inside. And you can see here they've got a mixture of basically A's and B's. And so it's really up to you basically how you do it. So that's how you would draw it up basically once you start doing it. So what I thought we'd do is probably do this one here first because I've got an answer guide for this one. And so what it's got here, so it gives us our specifications. So it says it's N2 wind rating. It says gable ends with a skewing roof on the garage. Now, don't worry about the garage because if you're not understanding the drawing, these are basically your piers on here, which put the brickwork, and they're actually, as you've seen if you've done much sort of brick veneer home, normally in the garage, there won't be any timber frame there. A lot of builders do that where they just have it all brickwork and have those piers basically all the way up, and so they're actually bracing themselves. So you won't have to do anything in the garage. So when it says option for wind direction A lot of people look at that and go, geez, what are they asking me? And what we're trying to get at is when you come back here, it's really just trying to get you to step through the processes. So when it says, let me bring that back up. So when it says option type for wind direction A, what we're wanting you to write is, S1, S2 or S3, or if it's a double story and you're doing the lower level, L1, L2 or L3. So it's really just getting you to write down what they are. So then you can write in there, that for wind direction A, we can see is coming from this way, from basically the bottom of the picture up, and you'll go, yep, that wind direction is going to be, I don't know, S3 or whatever it would be. Then you can then go to your table and go, this is the amount of bracing units that I need, and then you can do the opposite from the other direction, and then just go, okay, it's basically option S2, and therefore I need 25 units. So once you then work out those units, and so then just draw them on where you would put them, and I'll bring up a little answer guide, and I'll email that over to everybody. And yeah, so let's leave that and have a crack at it. If you're lost, and yeah, have a go at it. And if it doesn't make sense, let me know, and I'll sort of step you through. And I can send over the answer guide too, which you can probably refer to as well to see how how Steve's done it, because Steve writes the curriculum, and we'll basically go through it. And if you have done this exercise before, guys, and you're like, hey, I'd like to basically do this again, all you could do is basically just change the win rating and just make it an N1, and that'll then make it a fresh exercise for you guys again. So what we'll do, I'll leave it with your guys' hands now. It might take you, 10, 15 minutes, however long it takes, but maybe just when you're done, just type in the box finished or done or something, so then I know that you're done, and I can bring up the answer guide and we can basically talk through it. And any questions, I'll just be sitting here, so yeah, basically just ask me if you get stuck. Yes, that's so the roof pitch on this one. Yeah, that's a good that's a good question, Michael. Pretty hard with that. Why don't we just make it over 5 degrees? So we'll just say that it's 20, 25 degrees if you like. I didn't notice that wasn't on there. All right, so yeah, so with yours, Subit, yeah, you are correct. So when it says the total bracing units required, that can be a mixture of whatever, but it's always that number. Let me come back here. So the number they give us when we come to this table is always going to be type A bracing units. So when we use type A bracing units, as I said, it can be that nominal bracing if we like, or it can actually be our structural wall bracing. It's just basically, because as we know, if we've got 7 meters of single-sided plasterboard, that's one type A unit, or 4 meters of double-sided plasterboard, that's also 1 unit. So yeah, it'll just be that's how many type A units. But my advice would be that when you design it, just say type A and type B, and you could just write down the bottom, my type B units are plywood bracing and my type A units are angle bracing or something like that. So hopefully that makes sense to the question you were just asking me. Yeah, 1 second, Wayne. Oh, sorry, a lot of ones coming through. Oh yeah, put up the plan. Yeah, no worries, a lot that might come in handy. Hey, sorry, I didn't realise. I'll shrink it a little bit, guys. So if you haven't got, does anyone actually not have this in their folder? Because if you want, I can email this stuff over if someone would like a copy. So, oh, it's a bit too small, isn't it? I just want to see if I can just get a little bit, put it about 60% and see what happens. That's no good. Maybe if I go like that. Can you guys see all the measurements from there? Cool. Cool, no worries, Alex. Cool, thanks, Dean. Just give the other guys a bit longer to get it done. Cool, thanks, Herbert. Cool, thanks, Alex. Alex, thanks, Jeff. Looks like half of us are done, guys, so probably another 5 minutes and we'll probably have it all done. Cool, thanks, Ben. Yeah, thanks, Tom. Cool, thanks, Michael. Cool, thanks, Nick. So how was that, Nick? Was that all right, mate? Obviously, you hadn't done this before. Got a grasp of it? I suppose we'll see when we chuck the answers up. Cool, what'll do, guys, looks like I think everyone's done. We'll just give it another sort of 2 or 3 minutes, and then I'll put the answers up and we can sort of compare them to see yeah, how we went. So the main thing we're, I suppose, really after is the amount of bracing units, and yeah, I suppose just looking to make sure that they're not spaced too far apart and stuff like that. Cool, thanks, Omar. Cool, thanks, Valavan. I think that might be everybody, guys. So I'll put it up. The answer, if you're still working on it, that's cool. I'll just show it up and show you how, one way of actually doing it. So I'll just actually go through what the answers were first. So the option for wind direction A was S3, which meant then we needed 22 type A bracing units. The option for wind direction B was basically that elevation of S2, and therefore we needed 22 type A bracing units. So the total number of bracing units was 33. So this is one way of putting our braces on. So as you can see, just to clarify it again, so that's type A bracing unit. So when we use a type B is basically worth two, type B is worth 2 type A's. And so that's why you'll see the mixture here, and that's why yours might look a little bit different, but it doesn't matter. This would have equaled up to the amount of bracing units required, And as I said to you before, I started in the corners with type Bs, and then they've just chucked a type A in there. Could be some sort of metal strap brace, basically in here. And then Bs, and you might find, I can't remember the last time I bought bracing, but some guys might go, geez, I'll just get ply and chuck it on anyway. And especially sometimes too, depending on your cladding, you might find a lot of your houses are over-braced because in Queensland we used to do basically a lot of weatherboard construction. And so what had happened was once you put your ply bracing on, you then had to go and pack out your studs. And so sometimes it was just easy to just chuck another brace on there. And so that's also an option too. So it's going to depend on the type of cladding and the line of work you're in. But you can see they've gone around the outside and then they've started on their internal walls as well. So it might be even interesting for you guys next time you're on site, just have a look at your bracing plan and you could have a look at it and go, okay, well, the Australian standard says I need 32 bracing units. How many did they actually chuck on this job that I'm doing? And it's something you could easily do, when you're having your smoker or your lunch, just pull out your plans, pull out your standard, and you could basically look at it from there. But just as I tried to tell you before, there was nothing that needed to be done. The explanation is the garage does not come into the bracing as it has engaged piers and is therefore self-supporting. So that's what these little brick-looking things are around the outside there, and this would be where our roller door was. So hopefully, Valorant, I'll unmute you there for a second, mate. Yep, fire away, mate. Oh, no, sorry, I've somehow muted you again. Sorry, mate. Oh, I don't know what's going on there, mate. It won't let me unmute you for instead of saying that it's sending you a pin. So for some reason you must have to put a pin in on your end because you're obviously dialed in on a phone rather than on the computer. Is that right? Sorry, mate, I don't have any idea what happened. I've never had that happen before, Valavance. To see how you go. While Valavance trying to see if he can unmute himself, I'll bring up this next exercise that we're going to talk about. And when you're unmuted, Valavan, I had to send you a pin and it's been sent. Just basically jump in, mate, and we'll take off from the question you had. So the next exercise I thought we would do, I'll just bear with me 1 second and I'll bring it up. Oh, the size of the plywood bracing? Yeah, so as far as the size of the plywood bracing, it states in our standards that it has to be 900 millimeters wide, and you'll see that on any of those pictures when it shows us in our Australian standards for our bracing. Actually, I'll just show it to you, it's probably easier. So we come down to our plywood. So it says here that each panel basically has to be 900 millimeters wide. So in order for it to be a type B, basically it needs to be 900 millimeters wide, and it needs to go from the bottom plate to the actual top plate. And it shows you here that we can actually have a join sheet, but it talks about how it's got to be nailed. So cool, Alex, I'll go there. So how do we get S2 for wind direction B? So let's just bring that up, mate, and we'll have a look. So wind direction B was coming from this way, and it's basically 12 meters because we don't need to, because the garage is actually basically self-supporting. We're only working out then the bracing on these parts of the wall. So therefore it's actually 12 meters. Yeah, bit of a trick one in there. Cool. So bear with me a second, guys. I'll just bring up this other one, and you'll have it in your folder. So just bear with me a second, and I'll bring it up on the screen. And I'm in Struggle Town today, working this computer. All right, so I thought there's another bracing plan which you guys will actually have in your folder, and this one here. So I'll just shrink it so we can all see which one it is. So what it is, we've got it's basically the same building, but one of them's basically doing it as a single story construction with a skillion roof of 3 degrees. So there's obviously the main thing you want to look out for is 3 degree pitch, and then do it again, but then do it basically then as a lower story for a 2-story construction with a 30-degree pitch that's basically brick veneer. So it's up to you. Obviously, once you draw one of them in, then yeah, it's going to be hard to actually then draw in the bracing for the other scenario. So my advice would be just do one of them, and I actually don't have an answer guide for. I've got the answers for how many units there are, but not actually where they're drawn. So, and if you have done the basically it before and you've done this, maybe as I said, just to try and refresh it for yourself, that you might do this one here. Keep it as a 3 degrees pitch with a skewian roof, and maybe do it as like the lower story of a double story construction. Maybe just change the scenario or change the wind rating, just so then it becomes relevant for you and you're not doing the same thing over and over. But have a crack at that one there. And yeah, so basically it's the same thing. The number of bracing units, what is the elevation? We're using S1 or L3, and then basically work out your units just like we did before. So what I'll do, I'll leave that on there, and then that way you guys can see it and basically work the numbers. And this one here is a little bit different because you're going to have to basically add up all these numbers together and basically see what they come to. So have a crack at that one there, and when that one's done, what we'll probably do, we'll go through the answers of them, and we might even have our break there, and then we'll come back. I know it might be 15 minutes earlier than normal, but we'll come back and start something a little bit fresh. Well, not fresh, but something new. Yeah, I'll try that now, Valovan. Give me a second. Yeah, mate, it looks like it's worked.
Okay, that's good. Thanks, Adam. Just ask him, the plywood panel, we're talking about 900 mil.
Yep.
And how do we decide how many panels we had to use it?
Yeah, no, that's so basically one 900 mil panel actually equals one type A or one type B bracing unit. So that's if you wanted to, because I know what you mean. Sorry guys, just going to change this screen for a second. Yeah, because when you look at this picture, it basically shows that that whole wall is ply, but you've only got to do basically 900 millimeters, and that's going to equal one type B unit. So if you obviously put another one next to it, then you've got 2 braces there. So ideally, I shouldn't say ideally, realistically, you're probably not going to brace a whole wall like that because it doesn't need that many bracing units on it. So the only reason you might do it is for the fact that you've got to pack out your studs anyway, and you're doing something as a weatherboard. But yeah, if you did one 900 mil, mate, basically that would be that unit there. Because that's what it says down here.
Okay.
Each 900 mil panel equals one base B unit. So looking at this, you've got 1, 2, you got 3 type B units there. So really 6 type A units with those 3 sheets.
So if that is the case, if you're doing like a type, 2 type B there, and then if there is a rule like a 9 meter apart, we had to do the bracing every 9 meter, or we can't go more than 9 meter.
Yep.
So if that is the case, and we are measuring from the end of the bracing or the wall to wall?
From the end of the bracing.
End of the bracing, okay.
Yeah, exactly, yep. Cool, so...
Thank you.
Yeah, cool, mate. No worries at all. So with that, Michael, are you talking, you want me to send you the actual drawing that I just had up? Is that what you're asking me to send you? You're asking me to send you this one here? Yep, cool, mate. I'll send it over. Just bear with me a second. I was only thinking, Michael, like how good's technology being able to send this straight over. I remember when I did my apprenticeship and everything was still done by fax, and the boss would have to get home and fax all his orders off the next day. Bugger that. There you go, mate. Hopefully that comes over. The same thing again, guys. Just let me know when you've actually completed it all. Cool, thanks Alex. Oh yeah, 1 second Subit, I'll just take you off, mate. Oh sorry, Nick's got a question there too. I'll just go to Nick first. So, did you want to ask me something there, Nick? I haven't seen that little pop up before. I'll take you off mute. You there, mate?
Yes.
Do you want to ask me a question?
Yes, Adam. You said, just wanted to clarify, this was a lower story plan of a 2-story building?
Yeah, so, well, yeah, it's actually the same plan, but just in 2 scenarios. So the first one here says that it's a single-story construction. So you do it once as a single-story construction, and then when you come over to this part here, when it says number 2, you do the same scenario, but the same measurements as a lower story for a 2-story construction with a 30-degree pitch.
Okay.
Yeah, so that's what I'm saying. So if you've drawn in the bracing, you obviously won't be able to draw it in again, but at least you can work out what the units are.
Might as well do the lower story of a 2-story construction since we haven't done that before.
Yeah, okay, cool, mate. No worries at all. Where are we, Subit? Cool, thanks, Jeffrey. All right, fire away, Subit. I got you off mute, mate.
Yes, Adam, I think I thought I knew, but I got myself confused now.
That's all right.
It's again between structural and nominal bracing, yeah?
Yep.
If we look at the answer you explained just now on the first example,
Yep.
Do you have that page there?
Yeah, yep. Oh, what do you mean on this one here, you mean?
Yeah, first answer.
Yep.
Yeah. Yes, on these planes here we can see structural bracing A and B. Yes?
Yes, yeah, on these red.
But my question, yeah, these are all structural bracing, yeah?
Yeah, exactly, yeah.
My question is that I thought we have to work out the total bracing, which includes some nominal bracing. So where are those nominal bracing?
Oh,
Do we
no,
have to?
Yeah, that's easy, because the thing is, what's we're looking for? Your house doesn't necessarily have to contain nominal bracing. It's only if you choose. So let's say, if you can see my picture here at the moment, you might choose where this A brace, if you can see my mouse moving over on bedroom 1, if that wall was long enough, which it is, it's going to be, roughly 6 meters long. You could put plasterboard on either side of that and use that as instead of an angle bracing, but you don't actually have to use nominal bracing. You can decide that, hey, I'm going to put an angle brace in there because, depending on what your wall lining is, it might not be acceptable to use nominal bracing there. So don't stress too much about nominal bracing. I would just, it doesn't have to be designed into the house. I would just basically work out your bracing units as if they were either going to be ply or strap, and just leave out the nominal bracing altogether. The only reason you need to know nominal bracing is just in case you get asked that in a multiple choice when it says what percentage of nominal bracing can you use.
Okay. So my question just now is in table 8.2, because we work out this bracing A and B here on this plan based on table 8.2.
Yep. So
those numbers that really mean structural bracing.
Exactly. It says number of type A bracing units, so however many type A. So that's just it. So when you come down to here, so that's the thing. So when you just basically pick, that's a type A, so you could actually use those if you wanted, or if I come up on my screen a little bit, this is type A as well. So that's how many of those you need to use. But as we spoke about before, you might find that the house isn't big enough to put 22 of those on there. So that's when you can actually start to use type B as well. But so it's type A units.
What I meant is that, say, for example, if you look at table 8.2,
yep,
it says at the top, amount of bracing. So it should actually mean amount of structural bracing. Am I right or wrong?
Yeah, it is. You're right. It's the amount of structural bracing. But what happens is, just remember, structural bracing, should you choose to, can be replaced with nominal bracing.
Okay.
If you choose to. So it's basically telling us how many bracing units, which are right, and how many structural bracing units. But if for some reason you chose to take out a structural bracing unit, you could put in a nominal bracing instead if you chose to. But hopefully, I sound like I've probably confused you, have I?
Why are we given that freedom? I thought structural bracing is to give that structural integrity.
Well,
But
it
if
is,
we,
but what they've obviously gone and tested and realised that if they use 4 metres of plasterboard on either side, that's just as strong as what a structural brace is anyway. Because if you use a nominal brace, it's also got to be fixed a certain way. You can't just, chuck a little, a 600 piece of plasterboard on there. It actually states that if you want to use nominal bracing, if we look down here, if you want to use nominal bracing, that it's got to be 4 metres of double-sided nominal bracing. So no, that could be your plasterboard. So either side of a wall, both parts being 4 metres long, and if that's got plasterboard attached to it, as per the Australian standards, that's just as strong as what a Type A structural wall brace is.
okay, I got you now. So you're saying that on the diagram we have the type A, type B there, but we can choose to replace this type A or type B by doing nominal bracing.
Exactly right. Yeah, I said, and in reality, when you go for your interview, I wouldn't worry about doing that. I would just say I'm putting a Type A metal brace there, or I'm putting a Type B plywood brace there. But the only reason I like to cover that nominal bracing is because it comes up quite often in a multiple choice where they say, what percentage of nominal bracing can you use?
Yeah.
Because as you're right, you could actually go and replace these with nominal bracing, but you can actually only replace up to 50%. The other 50% has to be structural bracing.
Okay, I'm fully with you now. Sorry for confusing
No,
other
mate,
people.
don't be sorry at all. I said that's what we're here for, and as I said, this is one thing that probably this and last week's basically module are the two that take sort of the longest to explain and to learn. So mate, no worries. Or if you've got any questions, definitely let me know. And we want to make sure you understand it, so when you're going for your interview, you actually get it passed.
In fact, my second time doing this module, but I was very pleasantly surprised that I learned something very new.
Yeah, okay, that's good. And I remember myself, even the first time I did it, I thought, I'm a carpenter, I know how to do bracing. And then I looked at this and I went, I've got no idea. I just know how I've got to fix it. I've got no idea. And if you would have said to me, hey, Adam, where would you put the bracing? I would have said, I'd put ply here, I'd put angle there. But before doing this course, I would not have known, that I needed 22 and I could, then if I use type B, I'd only need 11. So I was the same. I find this a really good unit. And it's something we can actually use as well when we're on site and sort of, have a look at the jobs they're doing and see how much it is over braced or whether they've just gone with the minimum. All right, cool, so guys. So I think we'll maybe give it another 5 minutes, and looks like most of us, probably half of us are done. So yeah, looks like half are done. So yeah, we'll give it till what's the time? Give it another 5 minutes. So in 5 minutes time, so if you want to quickly grab a drink or something, I won't go over the answers for another 5. We'll let those other guys finish. Then we'll go through the answers, and then we'll have a 15-minute break. Cool, thanks, Ben. Cool, yeah, Nick's done too. Excellent. So just give it another couple of minutes just in, and then there'll be one or two more still going. And just in case a couple of guys did duck off to go and grab a drink, I'll just yeah, give another 2 minutes and then we'll go through the answers. Cool, thanks Omar. Yeah, Tom's done. All right, guys, we might go through these answers. So as I said, I don't actually have a PDF with the answers drawn on there, but if you do what you did on the last one, and you just start on the corners, work your way evenly, and yeah, you really can't go wrong. And as I said, we could all do this exercise and do it differently and still get it right. So bear in mind too, I find normally if someone gets this incorrect, it's just normally that they've gone to the wrong table. So just be really aware of the information that you're given. So we've got here that it's single story, then it's a 3-degree pitch, and the wind rating is an N1. So if you've gone and obviously done your own version because you've done this before, then your answers are going to be different. But basically the direction for the north option, you should get S3, and therefore the number of total bracing units which are type A for that direction should be 20. And then the direction for the east option, no, exactly, Valavan. It doesn't matter basically what our construction is, whether it's weatherboard or it's brick veneer. They've just chucked that on there. Yeah, it doesn't matter. So yeah, so the east option, the wind coming from the east is, or you might have gone, what's that, northeast or the west, whichever way you worked from. The east option was S2, and therefore the bracing units was 10. And so therefore the number of bracing units for that building was going to be 30. And then over on the next one, this is where I find normally if anyone messes it up, it's normally on this one because we're doing a lower story. So look at our information they give us. So this is the lower story for a 2-story construction. It's 30-degree pitch, and it's an N2 wind rating. So our north option, we should have come up with L3. and therefore that would have been 38 bracing units. So you can already see how many more bracing units we need compared to the one on we just over here for the single story on the same type of building. So 38. So then the other direction for the wind, which is our east, was L2, and that would have been 22 bracing units, and therefore we needed 60 in total. 38 plus 22 equals 60, and yeah, you can see there basically the amount of bracing that it needs is double. And so yeah, once we start getting a two-story, and obviously our different wind classification, and also the pitch as well, as you can see, it has a big factor on the amount of bracing that we're putting in there. So if what we'll do, guys, we'll go and have a 15-minute break. We'll come back at, well, my clock says 7:20, so we'll come back at 7:35. And if anyone feels like they need a little bit extra on that, definitely let me know, because after the break, we're basically going to go on to a bit of wall framing, working at our lintels, and then we'll also I suppose our nominal fixings, because there are a lot of questions we get on our multiple choice as well. So yep, I'll send the answer guide over, no worries at all, Valavan, and yeah, we'll have a 15-minute break, and I'll see you then. All right, welcome back, guys. So I'll just show you what we're going to go on with the next part. I'll just close down some of these pictures. All right, so what we'll do from here, we'll do this exercise, but what I'd like to do is actually just show you a couple of things in your Australian standard. Well, not a couple, basically go through our Australian standard, make sure we've got it basically tabbed and highlighted. And it's up to you how many tabs and how many highlights you want to put into it. I'm a big fan of highlighting a lot of stuff. But then after a while, once you get used to using that standard, probably remove a lot of the tabs. A lot of the guys I train find it just gets a bit too confusing by having them all there. So I just thought we'll go through our standard and make sure that we've got all the parts that we need to have highlighted and easy access for our interview and or our multiple choice question. And then we'll go on to this exercise here. Because basically, it's sort of one of those things. I'm a fan also of getting you guys to probably answer this without telling you what to tab and what to highlight, because it sort of then helps you find the answers a lot easier. And I just think that sometimes it's good if you sort of get thrown in the deep end and it sort of forces you to learn how to find stuff. But probably just with the limitation of the online system, I normally do them my face-to-face, but on the online, I don't, because if someone's sort of struggling a little bit and they're looking for ages, I can't see that. Whereas in a classroom, I can go up and say, hey, which part are you up to? And they can say, I can't find this part where it talks about fixing the noggins to the studs, and then I can sort of assist them. But so we will just go through it, and not everything obviously I'm going to give you is basically going to be the answer to this sheet we're doing here, but I just think we need to cover it off so you guys have the most important part of this Australian standard basically highlighted and tabbed. So just in case you missed last sessions, I'll do the whole 1684. And the reason I'll do the whole one is because next week we'll actually be going on to masonry, and we won't actually be using our 1684 again until it comes around again. So the limitations is something I brushed on in the beginning of tonight's session, and limitations is basically saying this is what this Australian standard is limited to. So as far as our wing classification, this one is limited to N1 and N2. So I'm on page 8 too if you've got your hard copy and you want to follow along. And talking, and you don't need to know this, I suppose, but it does actually tell you if you want to know what is actually N1 and N2. But down here, here's some limitations that we need to know. So the maximum number of stories of timber framing shall not exceed 2. And as you remember, this is just as far as this standard goes. We've all built houses that are probably bigger than 2 stories. The width, the maximum width of the building shall be 12 meters. That's excluding the eaves. And gives us a little picture there. And if you're wondering, going, hey, why didn't we just do that bracing exercise and it was 18? But the width, as you can see, is basically this part here. It's not talking about this return. All right, wall height is 2.7. Our roof overhang, our rafter overhang is 750 mil. The maximum pitch roof we can use with this standard is 30 degrees. And because this is a PDF, we found this last week that sometimes the things don't show up that well, but that's saying 30 degrees or 58 to 100. And the maximum spacing of our rafters and trusses should be 900 mil for tiles or 1200 millimeters for sheet roofing. And then the spacing of bracing elements measured at right angles shall not exceed basically 9 meters. Sorry guys, I'm just scrolling through. These sizes and tolerances, this isn't something that I've had any feedback from any of the students that I've trained have actually gotten, but I know that Steve, the training manager, he likes to talk about it. Just basically a table, and it talks about basically the alternative timber dimensions, what minimum seasoned timber dimension, and then the allowable basically for unseasoned. So it talks about, obviously when they, the alternate when you change them, and then also the size tolerances of how much they can actually tolerate in the actual size of that timber. Well, I went through this one last week just for the guys who maybe aren't carpenters, and when we use this standard and it talks, we're talking about different members. If you're not too sure what a hanging beam is, collar ties and things like that, here's basically just a good picture that shows you what these different elements of our frame are called. So if that's something you're not familiar with, then there's a good picture of it there. All right, so this is something, if you've been doing this course for a while with me, I'm sorry that I keep telling the same stories, but I just know that some people drop in and drop out. So one of them is vertical lamination. So vertical lamination is basically talking about when we're nailing some timbers together. And so it talks about here, nails shall be at a minimum of 2.8 millimeters in diameter and shall be staggered as shown in figure 2.8. So when we look over here, and talks about if you can use screws and so on, but basically this is what we're talking about here. So if we're joining basically two bits of timber like that are on edge, so this isn't for top plates, it's for timbers basically like that. So it could be, I don't know, strutting beams, probably bearers, maybe floor joists, hanging beams, things like that where they're on edge. The way that it actually works is you obviously put the two nails there, and then the spacing of these nails can't be any further than 2 times the depth of what the timber is. So obviously if that was, make it round figures for me, 100 millimeters deep, they couldn't be any further apart than basically 200 millimeters, and they need to be staggered as it is there. One down the bottom, the next one up the top, next one down the bottom, next one up the top. So that's basically how that works. And then it talks about the same stuff here on doing stud lamination. So if we're basically joining two studs together, it talks about in there how they've actually got to be fixed together. And then this one here, and this will be something that we'll do tonight, and it talks about basically the horizontal nail lamination, or wall plates only. So this is basically like your top plates and your bottom plates, so wall plates that are made up of more than one section. So for example, there's two 35 by 70s, shall be horizontally nail laminated in accordance with figure 2.9. So let's just see where 2.9 the figure is. It shows us here, and it basically shows where we've got to put those nails in, and it gives us the measurements and so on through there. So I won't bother reading through all this tonight, guys, or otherwise we'll be here till midnight. But I just want to make sure we've got these things highlighted, and they're pretty self-explanatory, most of them, and if they're not, I'll talk us through it. But that's basically how we've got to nail our wall plates. So that's a little bit of definition about what span is, single span and continuous span. So we would have touched on that last week when we did our bearers. And then when we come down here, there's some pictures of it as well. And then this was about our footing classification. So if you're not overly familiar with when we're doing our footings, this is on our bearers and joists, and we've got like a stump in the ground. There's basically 5 different types of footings, and the number determines like footing type 1, 2, 3, 4, or 5 determines basically how big basically the concrete pad is, I suppose, in the bottom of that footing. But we've just got to be mindful that there's actually a KPA basically bearing pressure for those types of footings. So it might be something you'll get in a multiple choice. So I've just got that tabbed and highlighted as footing classification. And then if you go over to this table here, this basically talks about how big basically that footing pad needs to be for our different types of footing 1, 2, 3, 4, and 5. All right, so some of you guys are doing some of the multiple choice online as you're practicing waiting going through your interview. You might see there's some questions there talking about how far out of the ground a stump can be and how far they're actually got to be embedded. And so this talks about it here. So it talks about the above ground height of any stump or post determined using table 3.2, so this table here, shall not exceed 15 times the required face width or diameter. So basically whatever diameter it is, or the face width if it's square, then it can't be more than 15 times basically out of the ground. And then it talks about the embedment, so basically how far, because whilst we talk about how big our pad footing needs to be, this talks about how far it actually has to be embedded into the ground. So if you're doing multiple choice online, you might be seeing some of those questions, and that's what it's relating to there. So I've got this highlighted as well. So last week when we did our subfloors, and we basically went through, and the way that I do it, I work out on my bearers and joists, and then come back and work out my footing classification after that. And so this is actually the table where it gives us the footing type we can use for the certain bearer that we're using. So we covered that last week, but I've got that highlighted. This is something Steve's got highlighted because he goes that he did the PDF. You know, just about the different types of notches and so on. So nothing that we really need to explain, and something you would probably find on your own anyway, because you'd be going into your floor framing, and it might say, you know, how big is the hole you can put in a whatever size joist, and you come down here, and this talks about, you know, basically the size of the holes for penetrations through there. So I'm just scrolling here. So this is one thing we did cover last week, but make sure you've got it basically tabbed if you haven't already. So basically this is about our solid blocking. So when we've got a joist, if it's basically 4 times higher than what it is wide, so making it easy measurements for me again, if it's 50 meters, that'd be good, 50 millimeters wide, and it's 200 millimeters high, that is then considered a deep joist, and therefore, because it's a deep joist, we need to put this solid blocking in there. And yeah, we can use, it talks about we can use herringbone strutting, which I showed you guys last week. So I've got that basically highlighted and tabbed relating to my deep joists. All right, that one there basically showing how yours on page 41, basically how your flooring needs to be laid when you're doing your yellow tongue or your red tongue or whatever sheet flooring you're using. And it talks about how they're going to be staggered and the nails that you've got to put in. Sorry guys, I just had to mute myself for a second. I had a big sneeze. So this is something too. This is still in our wall framing section. Sorry, when I get down to our wall framing section. So now we're in wall framing, and this is something we'll do tonight, and it talks about basically the blocking that we put in between our wall frames. So things quite often in your multiple choice. So a minimum 200 millimeter long stud size block, and they can't be any more than 900 millimeters apart. So and that says suitable for external brick veneer walls. All right, so here's a big one too. Basically holes and notches in studs and plates. So just be aware, you know, depending on the symbol, will bring you back to this table. And so then you can see, okay, am I putting a brace in or what am I doing there? And that'll then tell you how basically, sorry Val, I saw your question, I'll get back to that in a sec. Basically how big the notch is. Sorry, so with yours, sorry Val, that was about 5 minutes ago. So is that in relation to the vertical lamination, mate? Is that what you're asking me? Yeah, 1 sec, mate. I don't know off the top of my head. I don't think so, to be honest with you. No, no, it says, or it does say, so Valentine has just asked me, with the vertical lamination, do you have to use that nail pattern I was showing on both sides? And the standard says they shall be through nailed and clinched or nailed from both sides. So yeah, basically either way, you probably find guys will just do it from both sides just to be safe. And I've probably told this story to some of you guys before, but one of the guys I trained face-to-face is a site supervisor with Porter Davis, and the client actually, whilst Porter Davis had their own building surveyor come out and do inspections, the client chose to actually have a private one come out, and the private one picked up basically the lamination on the studs where they put some jam studs in. And yeah, he basically, the site supervisor then had to call back the tradie and say, mate, your frame hasn't been signed off, you haven't actually put enough nails in from your jam stud into your into your secondary stud. All right, so here is basically those notches I was talking about, and just be aware of these little notes down the bottom that we can actually notch at 25 millimeters for baths. So we'll do waterproofing in the coming weeks, and we'll talk about that. And then it also says except as permitted for diagonal cut in bracing, notches up to 20 mil may occur in every fifth individual stud. So, but you obviously not says except as permitted for diagonal cut in bracing, then yeah, basically otherwise every fifth stud. So we'll scroll on past that one. Talks about our noggings. You know, they can't be any more than 1,350 millimeters apart. And when we stagger them, it'll show that somewhere here, and I've obviously gone past it, but there is actually no further than 150 mil apart. So I've never done a wall frame where I haven't actually offset them exactly like that. But if you had to, the maximum you can offset those noggins is 150 millimeters. All right, so for those guys, we don't actually have Greg here tonight. Greg would be someone who'd probably be interested in this next one. So tonight, once I finish going through this standard, we're going to go through concentrated loads. And don't worry if you don't know what a concentrated load is yet, but basically this here talks about studs supporting concentrated loads. Now, you'll never be asked to do this like when you do the maths on it. Oh, you are here, Greg. Cool. I didn't see you sign in tonight, mate. So when we're doing some computations later on, one of our jam studs is actually supporting a concentrated load, and we'll talk about that a little bit later on. So when you actually go to the span tables, it talks about if you're doing computations for concentrated loads, then it basically refers you back to here, and then it then refers you to somewhere else and so on, and you can actually work it out. So just in case those guys are wondering, hey, how do you actually do that? It is actually on this page here, but don't worry. I don't know of anybody who's ever actually been asked that in their interview. It's just for guys who like to, I suppose, know every little part of the book. That will tell you how to do it, but it's pretty full on. You've got to work out basically the percentage of the roof that it's actually supporting, and then be able to work out like then, okay, what is the weight of that load, whether it's tiles, and yeah, it's pretty in-depth mathematics. So you won't be asked in your interview, but it does pop up. So this is it here. You've got to basically work out, okay, that stud is actually supporting this because that's a concentrated load on this reason there because they've got some sort of purlin through there and or hanging beam, and therefore they work out the area of that and then what percentage that is of the roof and then calculate that onto the stud. So yeah, as I said, not something in this course and not something you'll be asked, but it does talk about it should you want to learn the standard in a little bit more depth. All right, so down here we start to talk about our bottom plates, and one thing you'll see tonight when we do these exercises, that when we design our bottom plate, it might be something like 245 millimeter, 290 by 45 millimeter bottom plates, and most of us will say, geez, I've never done a double bottom plate before. And that's when you read through here, because it talks about basically if our bottom plates are supported by floor joists that have that blocking that I spoke about, or a concrete floor, then our bottom plates may be 35 millimeters in depth for any stress grade. So that's why we're seeing stuff tonight, probably for you guys who are familiar with framing and go, geez, how are they getting away with this on site? And it's normally because little clauses like this. And the funny story is one of the guys I trained face-to-face went for his interview recently, and at the end of his interview he was asked to do some computations on a wall frame, and he basically put his bottom plate in as 35 millimeters. And at the end, when the assessor, it was Rob Welsh, was going through his assessment, he said, yeah, mate, you did really well, except you got this this bottom plate wrong. It needs to be 245 by 90s. And the student, Jared, said, no, actually, if you look at this section here of the Australian standards and showed him, it says, you know, if it's on a concrete floor, which this diagram is you've given me, it can actually be a 35 millimeter bottom plate. And he went, oh. And the assessor, Rob, said, oh, okay, I didn't realise that. So obviously with their answers they get, they're probably given an answer sheet as well. And so that's why my advice would be when you're actually doing any of these exercises, I'd be doing it as per the table. And then that way it'll match up with with what their answer guide shows them. Because I know myself, like I do training other than the builder registration training, I do a bit of diploma and certificate 4 training, and when I'm assessing people's work, if they give you something that's out of the box and it's not sort of what you're expecting, then as an assessor, you know, I go and then research it and go, hang on, that answer might not be wrong, and then you go and try and find, go, okay, that actually is right. But my advice would be try and make it as easy as you can for the assessor, and if that table says, you know, 245 by 90s, that's what I'd be putting in there. And if you are quizzed about it, well, you can show him back here, but I'd be putting it in as per the table. All right. This one here, this is one of Steve's favourite ones, and it just says, this is talking about our lintels, and because we'll do some lintel design tonight, and it says the actual opening widths may be varied by up to 70 millimetres greater than the maximum spans given in the table. And I don't know, it just seems silly to me. Why say this span is 2.4 if you can make it 70 millimetres larger? But anyway, it's in there. All right, cool. Yeah, that's one there. It just talks about, and this is some stuff you guys would find out on your own. It just says the size of lintels in gable end walls not supporting roof loads shall be determined as for lintels supporting sheet roofing with a rafter or truss span of 3 metres. So same thing, I haven't heard anyone who's actually basically ever been asked that. And normally in my face-to-face classes, I haven't really had to go over that, but just because it's highlighted there, I thought I'd explain it to you. Oh, and this is another thing too. So keep note of this, highlight this one, sorry, I should have told you this. On page 55, note the size of lintels required to support concentrated loads may be determined from Australian Standard 1684.2 or by engineering design. So definitely highlight that, and we're going to cover in a fair bit of depth once I get through this standard what concentrated loads are. All right, for those of you guys who have actually been doing multiple choice, and you've probably been getting this question and have no idea what it is, but you know the answer of it, and it says something along the lines of what is the minimum clearance at the support for a combined of the material, I think, the material lining for a ceiling, basically under a combined strutting counter beam or something along those lines. And the answer is 25 mil. If you're ever wondering what that was, this is basically the picture here. So that's something that yeah, you might get on a multiple choice, and yeah, and you probably would know the answer is 25 mil just from doing our tests. But if you yeah, wanted to know what it actually was, that's a picture of it there. All right, another one which comes up in your multiple choice is some stuff occasionally about basically your pitch roof or your conventional roof, whatever you like to call it. So I'm just getting down to it, which is about your collar ties here, and it just basically talks to us about basically the collar ties, and then comes in here about how long they need to be, and how they need to be fixed, and how they need to go into every second rafter. So a bit of stuff there on your collar ties if you wanted to highlight and mark it, because no doubt pitch roof probably isn't many of our strong points, I suppose. This one here, there's just a little picture. Sometimes you might be asked to draw that when you've got to fill in the missing details when you go in to do your interview. And yeah, that's just two different ways you can actually do your eaves. All right, this is one I would actually, probably more so for tonight. I haven't heard a lot of people had to do this when they've gone into the VBA. But when we're doing our span tables later on, just about every member size that we're trying to find is at the back in our span table index. But for some reason, our ceiling battens are here. So I find from experience, every time someone's done this unit for the first time, they've always said, Adam, I can't find the ceiling batten sizes. And that's because they're not in the span tables, they're on page 73. So if I was you guys, I'd basically just highlight that and chuck a tab on it, because otherwise guaranteed, if not tonight when we do the exercise, later on you'll be going, where are those bloody ceiling batten sizes? All right, so this I'm just going to flick over. This is what we did tonight with all our bracing. So if you're wondering why I'm flicking over it, we would have all basically highlighted this earlier in tonight's session. So I might do it this way to make it a little bit quicker. Alright, so this is the last little bit I think we need to do, and then we can get on to the exercise. So this here talks about, guys, when we've got a ribbon plate, so basically like your double top plate, and it shows us, if you can make sense of the drawing, I'll make it a little bit bigger, that on the bottom one, the join's on that stud, and then on this one here, the join's on the top over this stud, and the distance between those joins has to be 1200 millimeters. And then it obviously shows that we need to put nails on either side of the joint. And then on here, so this is nominal fixings. Definitely highlight this, and this is then talking, this is stuff in multiple choice you'll get, basically just the different size nails or fixings we need to use for our different timbers and so on. So here's for our plates to our studs, our bottom plates to a concrete slab. This will make you chuckle. 175 millimeter masonry nail that's hand driven at the slab edge, or we can screw or bolt at not more than 1200 millimeter centers. So yeah, I don't know anyone who's still actually hand nails. I know I did as an apprentice, but since I was an apprentice, I haven't. So that's your nominal fixings. Talks about how all that's got to be done. And then on this one here, same thing again, this is fixings again, but this is specific fixing requirements for wind classifications if it's in an N1 basically wind rating with a sheet roof, and that talks about it in there. And that really just flows on to the next table, and the next one as well talks then about same thing, specific fixing requirements for then our tile roof. So you maybe highlight those ones. So if I'm going too quick, definitely let me know as well. I just realised I've scanned over those last 4 pages pretty quickly. And then from there, the last tab that I have in my book is this part here, which is our span table list. So I've got a tab there. So whenever we're doing our member sizes, our bearers, our floor joists, our common studs and so on, this is basically where we come through in these tables here. And so that's basically, I said, what I've got in my Australian Standard, and sort of the feedback from the students who have gone through basically the VBA as well, what they've been asked. And so what I'll do now, I'll bring up this exercise that I think we should do, or we will do tonight, is just a few things that I want to explain to you. So before we were talking about a concentrated load. So just before you go and tackle this, and this is when you basically go in and do your plans, it's very easy, I suppose, to rush because you're looking at the clock going, geez, I've only got 2 hours to get this done. So try not to rush into it and just have a good look at it first before you start tackling it. So what I want to talk about is a concentrated load. And if we look at this picture here, so this is basically an elevation of that 3D picture we've got. And so you can see our hip on this building, if you can see my mouse, is pretty much in line with where that stud is for the lintel. So when I come back up to this picture, we can see that this truncated girder through here, it actually takes the load of all these creepers and jacks through here, because we've got the hip sitting on it, and then we've got these trusses in here which are actually then joined to that girder through there. So all that weight is actually sitting over that lintel. So that's actually what is a concentrated load. So as I got you guys to highlight before, we actually can't design using this standard concentrated loads. It's got to be done out of 1684.2 or by engineer design. And so that happens then with our jam studs on it as well. Because they're supporting a concentrated load, we actually can't design those jam studs either. So that's one thing I wanted to cover about that. And then the other one I wanted to show you, and I actually never really understood basically what this question mark was relating to. So I'm going to do my best to try and explain it with the limitation of this system. So for those guys who basically haven't done much roofing, I'll just start with the basic, I suppose, of the hip. So what happens with this hip rafter coming through here is that hips are going to be at 45 degrees. So in order for that to be 45 degrees, we need to know where to actually put this last common rafter, so that full rafter there. So the way we determine that is basically the span of this building, it tells us is 6 meters, I'm pretty sure. Yeah, so the truss span is 6 meters. So basically the half span is 3 meters. So if we come back up this wall here where it's got lintel 2 and lintel 3, basically 3 meters, that then there, once we put that truss, that common truss across, creates a 45 degree for that hip to sit on. So basically where they join up, and it gives us 45. So the reason why I'm telling you this is because when we're actually looking at lintel 2, it talks about the span of the load above lintel 2. And so you can see that span doesn't actually go all the way to that last truss. And so we wouldn't go on there and say, okay, lintel 1 is supporting a load that is actually got a span of 6 meters, because the 6 meters is actually across. So obviously lintel 3 would be supporting a truss. I might make that a little bit bigger. Lintel 3 would be supporting a truss that has got a span of 6 meters. So in order to work out basically how far this is spanning, we know that the length of this wall here is 6 meters. So in order to achieve 45 degrees, half of 6 is 3. So we come back 3 meters, and that's where that actual last common rafter sits. And it tells us here that our truss spacing is 600 millimeters. So this truss here, the girder that's got all these other little creepers and so on going into it, if we come back 600 millimeters, so 3 meters minus 600 gives us 2.4. So that girder that's basically taking all that weight is 2.4 meters back from the end of the wall. So that little truss that's sitting above lintel 1 is actually only spanning 2.4 meters. So when we go in to design the lintels, and it says, I forget how it's worded, but I think it might say truss span. That truss span on that is only going to be 2.4 meters. So that's what that's about. So when, just for a heads up for you guys, when we come to do this, you'll be able to design lintel 1, lintel 3, but you won't actually be able to design lintel 2 because it's got the concentrated load on it. And so just be mindful of working out these spans. And then from there, hopefully the rest of the stuff you guys can actually go through and answer. So the only thing it doesn't give us, because we're going to go through and work out all these member sizes, so we might just do it all as MGP10. So if we can do it as MGP10, then that way we can all end up with the same answer. And if some of you guys have done this exercise before and you want to participate because you feel like you need a little bit more I suppose study on your wall framing, just do the same exercises but make it a different timber grade. Make it F17 or whatever you want to. Then that way you're still working out what your basically the size of your lintel span is, and then also what your truss span is and things. You're doing the whole thing again, but it should be a little bit fresh because you're using a different part of the table. So, or you could even choose to make it a bottom story instead of an upper story or a single story construction. So if you want to participate and you've done it, just change the scenario, and then that way you'll get something out of this exercise as well. So yeah, so we'll just read through the information. So it does actually tell us that all studs are 90 by 35 MGP10. So so then when we actually go to do our wall framing, guys, it'll ask you whether you want to use 70 millimeters trenched and untrenched or something. But because it tells us our studs are 90, then obviously we want to have 90 mil top and bottom plate. So don't go and design me 70 mil top and bottom plate when we've got 90 mil studs. So we're going to use 90 mil studs. Our wall height is 2.4 meters. Our roof type is tiles. Our truss span is 600 millimeters. Truss span is 6 meters. Our truss spacing is 600 millimeters. Our ceiling batten size is 600 mil, and our wind classification is an N1. So also what it'll ask you to do is name the different trusses. So if you've got your truss standard there, you'll be able to name them as being your creepers, being your hip, being your truncated girder, a common, and so on. So you can actually put the names of the trusses under there, and then basically go through and then tackle these. And just before you do tackle that, I just want to show, just see if everyone's actually seen this. This is something that the VBA have been asking quite regularly when guys go in for their interview, is basically to design this. So I will email this over to everybody. And has anyone not seen that? Because I'll go through it in a little bit of depth later on if anyone actually hasn't seen it. Haven't seen it, Valman? Cool. No worries. So what we'll do at the end of the session, I'll talk through that and I'll send that over to everybody. And yeah, just a few things about it. You guys can, if we get a chance to have a crack at it tonight, but we might not. So I'll just email that out and you guys can have a look over it. All right, so let's have a go at this one here. As I said, I'll be sitting here while you do it. And if you've got any questions, let me know. And yeah, we'll go through the answers once everybody's done. So enjoy. Sorry, Alex. No. So when it says notched, no. So what they're talking about there, Alex, is I'll give me a second. I'll pull up my standard, but I'm pretty sure they're talking about notched in the bottom. So just before I give you around the wrong way, give me a second and I'll bring it up. So when it's not quite. I might take you off mute for a second, Alex. Are you talking? The only part I can see is where it says trenched. Are you talking about trenched, or are you talking about notched? I'll just take you off mute, mate, or unless you don't have a mic and you want to type. Okay, I just got you off mute if you'd rather talk than type it.
Hello, you there?
Yeah, g'day, mate. How are you?
Yeah, good. I'm just talking about table A12.
Yep. Oh, so you're actually in the
so-
table itself, not on the table. Yeah, I'll get you.
Yeah,
Sorry.
yeah.
Yep.
Notched 20 mil max.
Yeah. So where's it telling you that it's notched?
You see, just for example, if I look at the wall height 2400, if I look at tiled.
Oh,
and
yeah.
then
Sorry.
over-
Yes. Now I get you. Yeah. So sorry. Yeah. Yeah, oh, that's not specified then, is it? Yeah, I suppose we'll want to, or just because the answers I think they've found up, they've gone not notched. So yeah, now I know what you're talking about. I thought you were talking about the bottom plates being trenched. So I think in this scenario, it turns out they're the same size anyway by the look of it. They're still all 90 by 35. But yeah, but that was a good pickup though. I didn't look at that, to be honest with you. So yeah, because obviously they are going to be notched for bracing and so on. You might have to allow for it. But yeah, so we'll go with not notched, but as I said, it wouldn't have made a difference on this scenario anyway.
Right, thank you.
Cool, thanks, Alex. Yeah, 1 second, Tom. I'll just figure it out, mate. I'll just bring it up. So lintel 2. Yeah, so even if that was basically, and I'll pull up another picture for you. So this is where guys get caught out a little bit when they go through an interview. So you get something like this, and yeah, when that's a little bit off center. These, if you can imagine, if that was basically over that fraction more, then even if you're on the bottom story, that concentrated load still basically goes down into basically the lintel as well. So you wouldn't be able to design that one either there. So if that basically back to what we're doing here, if that was under the concentrated load from the story above, then you'd still have to get it engineer designed as well. Is that sort of what you're asking me, Tom? Yeah, cool, mate. Yeah, that's pretty much right, mate, unless you want to go to 1684.2. But yeah, they don't ask you to bring that one into your interview. They just ask you to bring in 1684.4. So otherwise, yeah, you've got to go to that other standard or have an engineer design. So you could actually pull up that other standard. And I've actually got it, but I'm not familiar with it because I've never really needed it. I've only got it on an electronic copy. So actually, I should just have a bit of a look at it actually one day to see what it does actually talk about designing it. So that might be something yeah, as Greg will tell you, I like to look at stuff like that and try and figure it out. So if I get a chance in the next week, mate, I'll see what it actually talks about, how to design it for a concentrated load. All right, what I'm going to do basically now, guys, just while you're doing that, when I log on to the webinar, it tells me basically who's registered to actually come tonight. And I think we must have got a few people on who didn't register, which isn't an issue. That doesn't matter at all. But I can only get the email addresses of who's here from actually who's registered. So I'm going to send over some stuff now in an email that we've been using tonight. And if you don't get it, just say, give me 5 minutes. If you haven't got it, say, hey, Adam, I didn't get it, and then I'll email it over to you. Just remember to let me know when you're done too, guys. Since you've finished, Tom, had you seen this one here that I emailed through before? Because you're from Sale, is that right? Have I got that right? Yep, cool. And so you'd seen that? Did Steve show that one when he was down in Sale? Cool. Thanks, Michael. Yeah, cool. No worries at all. Cool. Thanks, Jeff. fire away, Valvan.
Hi, Adam. I'm looking at the answer that you sent for the bracing plan 1.
Yep. I'll just bring it up, mate. Give me 1 second. Yep, this one here.
Yep, that's one. And if you look at the one, it says the direction A, and we need 22 bracing.
Yep.
22 type A. But
Yep.
how do you mark it? If you count them, sorry, did you say something?
Yeah, no, not at all. No, you're right. So, yep. So it's
it says 22 type A.
Yep.
And I just counted, and looks like it has only 11 or 14 of them.
Okay. Did you count the Bs as being 2 though? Because remember the Bs are twice as strong.
I did. Yes. Yeah.
Okay. Yeah. I don't know. So let me count them up, and I said because I didn't actually. This is Steve's answering guide, so let me have a look at it, and I'll count them up.
Sorry. I made a mistake. I need to count it the other way. Sorry. Yeah.
Okay. Oh, so you've gone the wrong direction. Okay. No worries.
Yeah.
Have a look. If it doesn't make sense, definitely let me know.
Sure. Yeah. Thanks. Sorry.
You're all right, mate. What I might do, guys, is just give it another 5 minutes. Is there any? Maybe just type in the box. Is anyone actually still doing it? I've got a lot of people say they're done, but it's hard for me to keep track of everyone who's basically still doing it. So if you are doing it, just say still going, and we'll have another 5 or 10 minutes on it. And if you are done, then we can basically get on to the next part. Yep, no, it looks like everyone's done. So all right, cool. So we'll read through these, and so let me just bring it up. I better grab my answers so I can go over them, because if I go from memory, no doubt I'll get them wrong. So what is the size of lintel 1? So that's the one down here, obviously, where I explained the broken span. I think it's 2 of 120 by 35. And now with some of these guys too, for all means, if I say it wrong, definitely let me know, because with my notes, because I obviously train this over and over, and especially with my guys, I do it face to face, so I sometimes change it up a little bit, and I have 2 answers there, and I go, geez, which one's for which? So I think it's, I'm pretty sure it's 2 120 by 35. Our lintel number 2, that was the one that we said needed engineering because it was the concentrated load because of basically the hip and all the weight on that girder truss. So lintel number 3, 2 170s by 45. The next question was, what is the maximum corner block spacing? 200 millimeters is the size of the block as a minimum, and the spacing is no further than 900 millimeters apart. What was our bottom plate size? So I've got here from the table 245 by 90s, but as we spoke about, because it's on a slab, we can use a 35 millimeter plate if we wanted to. So the top plate size, 245 by 90 also. Our jam stun sizes for lintel 1, so basically the smaller one there with that little hip truss sitting on it, was 90 by 45. We can't do number 2 because it's a concentrated load, and lintel number 3 was 2 90s by 35. And then our common stud size, it did actually say to us at the top in our scenario that we were going to use 90 by 35 MGP10, so I've got that written there. Basically our plates to our stud fixings, and so, oh, this one I've got 2 answers for. So basically I'm pretty sure it's 290 by 35 because of the size of the timber. So give me does that sound right, guys, or do I need to look at the table? So plates to studs. Oh, so I'll go back 1 second, Alex. So I actually got a question there for me. So 1 second. So yeah, that is right, Tom. Thanks, mate. So Alex has asked me about the corner block size. So I'll just find where that one came on, mate. Give me a second. So that's on page 45. was on this one here. So that's that block there. That's something you might get in a multiple choice, Alex. Yeah, where it says there they've got to be 200 millimeters long and no more than 900 millimeters apart. So that's where that one there comes from. And so hopefully that made sense for you, Alex. So Tom's just confirmed that, yeah, the nails are 290 by 3.05. So that's basically what we're using to fix our plates to the studs. And okay, cool. So Valavan, so which one was that, Valavan? Are you talking about the nails or are you talking about the stud block? Sorry, the block in the walls there. I might just take you off mute, mate, and we can have a chat about it. Cool. So which question was that, Valavan? I've just got you off mute if you want to talk.
Yeah, can you hear me?
Yeah, mate. Yeah, go. Fire for it.
The lintel size and the lintel one, and I'm not sure how did you work out the size?
Okay.
I lost it.
Yeah, okay, it's cool. No, so I'll go over that. So with the lintels, so I'll come to basically we need to go to that table at the back. Oh, I'll just go 1 second, mate. All right, so we go to our span tables list, and what we're looking for down here, we'll see somewhere where it talks about lintels. Yeah, lintels supporting single story or upper story load bearing walls. So it's on table A24. So I'm going to go to table A24. All right, so this is our lintels supporting our single story or basically upper story load bearing walls. And so when we go to this, we need to obviously put our scenario in. So when we look at here, this whole table is actually, I'll make that small just for a second, is actually on a sheet roof. So we need to actually go to something that's going to be a tiled roof. So when we turn the page, this page here is all basically for lintels on a single story or upper story load bearing wall for tiled roofs. So then the next thing we need to be able to work out, we go, okay, we're on a tile roof. And then the next question in the box here is, what is our rafter or our truss span? So if we look back at our drawing here, it tells us that our truss span, this is for lintel number 3 I'm going over. So basically our truss span is going to be 6 metres. So therefore I come back to the standards. So tile roof, truss span of 6 metres. And then what's actually the size of the opening? So then we come back here, the size of the opening there is 2.4 metres. 2.4? Yep, so I'll line these up. So we go so tile, 6 metres at 2.4, and we bring that across. And what did we say we're using? It was MGP 10. Does that say we're going to use? Yep. So line that with MGP 10, and that gives us 2 170s by 45. So,
okay, yeah.
So does that make sense? And so then if we were going to do, I said lintel number 2 we can't do, but if we wanted to do lintel number 1, remember how I said when I look back at this picture that basically 2 there is 3 metres, so we minus 600 millimetres. So therefore that truss span now is actually only 2.4. So we basically do the same scenario where we go tile roof, 2.4 metre span, so it's less than our 3 metres, so we use this one here. And then we find out what our opening width was, and it's 1800 millimetres. And so we go 1800 and we bring that over, and it gives us 2 120 by 35. So if you like, mate, yeah, because you know you got those wrong, let me know, and I can probably send you over, see if I can find something else, and send it over, and you can do a couple of practice ones on that. So just remind me at the end of the session.
Sure, that would be good. Thank you. Yeah.
Cool. All right. So then, yeah, back to our other questions. Oh, I've lost it. So we've got our nail sizes. Our noggins to studs, they were 275 by 3.05 skewed. Our roof batten timber size is, where are we, 35 by 42. Oh, sorry, I missed one there, didn't I? Sorry, the bottom plate fixing with a Type A bracing is a 75mm hand-driven screw or bolt every 1200 millimeters, and then the roof batten timber size is 35 by 42. And now this is one that I find most guys actually getting correct. So don't stress, it's only a nail size. You're not going to not get your license because of it. But as far as the roof batten fixings, the actual size is 75 millimeters by 3.05. Now, did anybody not get that? I suppose most of you's probably got the next size down, which I think is a 50 millimeter from memory. So let me know if anyone didn't get 75 and I'll explain to you why. I find most guys when they do that don't actually get 75. Awesome, we all got 75. Geez, you guys are going awesome. So then, no, you didn't, cool. So let's go back to it. So the Australian Standard, no, yeah, I thought a couple wouldn't. So basically all that happens, guys, if I come back to page 103, it's just got to do with the minimum penetration you've got to put in basically into the truss or the rafter. So 1 second, I'll just grab my book because I've highlighted it in my book, and then I'll be able then to show you. So it's on page 103. So this is where you guys would have been looking. We would have probably found stuff in here, but then when we look a bit further, it says fixing requirements for tiled roofs, and it tells us on here that we need to have a minimum penetration of 35 millimeters, sorry, 25 millimeters, and depending on basically the wind rating, because one of this one over here somewhere else talks about the minimum penetration, but because basically our tile batten itself is 42 millimeters, so which one? I'm trying to think which way to go. Is 35 millimeters deep and 42 millimeters wide. So with the 35 millimeters deep, if we're using a 50 mil nail, which is probably what you would have written, I presume. Did you write 50 mil? Is that what the answer was for the guys who actually didn't get 75 mil? Yeah, you probably would have put this one here. So it tells us that if we're using a 50 mil nail, we need to have a minimum penetration of 25 millimeters. So when you do the sums, if you've got a 35 millimeter batten and it's a 50 mil nail, then it's only actually penetrating 15 mil. So that's why you need to then step up to the next one. So yeah, don't stress if you got it wrong, guys. I said yeah, it's only a nail on your roof batten, and realistically, you're probably going to use your 75 mil anyway because you're going to go along with your framing gun and put it in. So yeah, that's why we basically got that answer on that. And then the ribbon plate to top plate fixings, they were two, actually that'll be different. I've got here 275 by 3.05 nails, but I'm thinking if we went a larger top plate at 45 mil, it probably then goes up to the next nail, does it? That's one there too, where I've got two answers for it as well. From the different scenarios I've been running. So why don't we just have a look at those nominal fixings and we'll have a look. Or can anyone clarify that for me while I'm trying to find it? Because no doubt you guys have found it. So plates to studs. Yeah, so there you go. So plates 38 millimeters to 50 millimeters thick need 290 by 45. So, and I think from memory we said our top plates were going to be 45 mil. Yeah, 245. So yeah, because it's obviously that we need to step up the nail. So yeah, I'd be very surprised. Yeah, that stuff. I doubt anyone probably even carries any of the chippies 90 mil nails for their framing gun. So we're probably all actually doing 75 mil nails. But yeah, if you read the standard, we're actually supposed to be using 90 mil nails. And then the ceiling batten size was 35 by 42. So hopefully, yeah, that all made sense, guys. If I did get anything wrong, definitely let me know. Because as I said, I do this exercise and change the scenario. And when you see my answer sheet, it's got stuff written all over it. So I sometimes do get them a little bit wrong. Yeah, cool. I can do that for you, Valavan. No worries at all. So what I thought I'd do, guys, that's sort of all I wanted to show you tonight. And by all means, if you're going to come in next week, welcome aboard. We're doing the masonry. And I just thought I'd show the guys who actually haven't seen this plan before. There was a couple. Sorry, not that one. This one here. Basically, I thought I'd just run through it because you guys can have a crack at that, in your own time, or stay on, tonight after I log off and see if you want to do it then. But this is something that the VBA were getting guys to do, and down here is basically the scenario, and it says they want you to do the computations for the following. And some guys get a little bit confused when they look at the picture, because this is your GF with your ground floor. And then this is obviously the FF for your first floor, so the upper story. So on the ground floor, they actually see this dashed line across here, and that's actually the outline of the top story. So when you look over here at the elevation, you can see that it's set back a little bit. So therefore, when we're actually working out our floor joists, because that's obviously where your external wall is going to be, is going to sit there for your floor joist. It tells us that it's basically 5.150 millimeters. That's how long it is from there to a load-bearing wall. So when they actually ask you to do the computations on that floor joist, it's actually a bit of a trick question, because when you look at your standards, the longest span you can get out of this Australian standard we're using is 4.8 meters. So therefore you can't actually design a floor joist out of 1684.4 to actually span that far. So so that's why later on it then asks you to nominate a load-bearing wall. So what you would do is nominate this wall here, if you can see my mouse, as load-bearing, and therefore it breaks up that span, and you're only really getting, I suppose, roughly about 2.5 meters. And you've already got a span over here of 4.5, and so that span would easily cover what is basically going on here. So that's the bit of the trick question in there. And then the other stuff is pretty self-explanatory, basically about, it says your floor joists, and it's only because it's on a concrete slab, it's obviously only on the upper story, it's not on the bottom. Your top plates, they want you to work out your studs, and then I'll get to that in 1 second, Jeff. So basically then ask you to basically do these lintels and so on, and just because this drawing here should be over fractionally, it's probably, or you're supposed to make sense. It makes, no, that's all right. So when you see, it doesn't actually have to be under the hip, it's under that truncated load. So I think it might be different on the actual answer guide where they're positioned. But where it's a little bit tricky is when you look at the floor plan here, and that's actually in the wrong spot. It doesn't actually meet up. So you can see where it says 2.7, and that actually doesn't sit underneath that that hip section, whereas on the elevation it does. So you should be going off the elevation, and because those are under there, basically then you can't computate them up because they're a concentrated load. So that's, I just want to cover that with you. Have a crack at it if you haven't, and see how you go. I'll send over the answer guide so you can do it as well. And so I've just got a question here from Jeff. Bear with me 1 second. So that was on the exercise that we just did before previously, Jeff, on this one here. Yep, cool, mate. 1 second. So Jeff just asked me a question. He's saying we said that we got 290 by 45, but he got 290 by 35 for his top plate. So bear with me 1 second, mate. I'll bring up the standard and we'll have a look. Oh, Ben got it as well. I said, and that could have been something on my end from the two exercises I've done. So let's have a look. So let's just go through it. So what are we doing? Top plates is on here. So top plates, and we're using 90 mil because obviously we're using a 90 mil frame. So top plates not trenched, single story or upper story external load bearing walls. So we're going to table basically, so you would have different fixings. So that's why, of course, I know why he's did it. Yeah, that's it, because it doesn't actually say on there whether we've got our studs at 600 spacing or 450 spacing. And that's one thing, I've got it handwritten here on my notes to actually put them at 600 millimeter spacings just to try and get guys to do something a bit different. But if you would have done 450 spacing, which we normally do, then you would have got basically a smaller size top plate. And then obviously with the smaller size top plate, then you would have had smaller size fixings because you would have only had to go through a 35mm top plate into your stud. So yeah, sorry, because that was probably my bad, because on this drawing here, it doesn't actually state what our stud spacing is. So I normally, say, okay, let's use 600, but I forgot to actually mention that. So that's all good. That was a good pickup, Jeff. So so if you did get different size top plates, it was probably to do with your stud spacing. All right, so yes, that's pretty much all I wanted to cover with you tonight. I've emailed that stuff over, and this is something from the VBA. So yeah, have a crack at it if you haven't already and see basically how you go with it. And I'll catch up with you next week. So if you want to hang on for a second, Valavan, and I'll have a chat. I'll just take you off mute if none of the other guys have got any questions. So with that, Subit, no, I actually don't. Oh, hang on, I might. I'll have a look to see if I do actually have answers for that. Yeah, thanks, Dean. I don't think I do, mate, but I'll have a look. I'll just take some notes on this, mate. I reckon with those things you're after the answers for, Subit, I reckon maybe one of them I do, which is probably the hand-drawn one. But yeah, leave it with me and I'll see if I do, and if I do, mate, I'll send you an email either way. All right, so I'm just going to stop the recording there, guys. I'll stay online, obviously, if anyone wants to keep chatting. All right, thanks, Jeff. Oh.